Mic testing, mic testing, mic testing. Okay, let's continue. The second part of the lecture, we will continue with semiconductor. Few more slides, then we end the lecture. So what I mean by semiconductor? The keyword you can elaborate from the wording itself. Conductor means something that you can transfer either energy or thermal energy. So semiconductor, they are neither good electricity conductor or good electricity insulator. They are not good or not good. Right? It depends on how you make them. Okay. So their ability to conduct electricity is intermediate, means they are between conductor and insulator. They're in the middle of conductor and insulator. So if you look at the free body, you look at the periodic table. So they highlight what are the main ingredients that can make up a semiconductor. So you have those light blue here and a bit deep blue. So all these highlighted elements, they can form semiconductor. All this you can read, the description you can read from the slides, but at least you can identify the elements that you can form a semiconductor. Keyword for semiconductor, again, they are intermediate for their conductivity and either they can between conductor and insulator. Take note that semiconductor, they do not fit into any structural material categories. You cannot group semiconductor based on their atomic bonding. You know that atomic bonding in your chemistry, you have single bond, double bond, triple bond, ionic bonding, covalent bonding. Semiconductor you cannot group semiconductor based on atomic bonding. Then this one is another add-in material. Something we call it smart material. With its recent years, I think it's your time that you expose to all these advanced material. One of it is called smart material. Smart material, they can sense and then react. They can sense, respond to the environment. Then it fall under category called smart material. Okay, they can sense it and then they respond. Respond either by smell, color, mechanical properties, movement, motion, and so on. Okay, so application of it is two big category or general example they can give under smart material category. sensor and actuator. Okay, so sensor, it means something that you can sense a change. Sometimes smart material, they just change color. Example, because I'm from aerospace industry, if you take an aircraft, different height have different temperature, right? So as it become colder and colder, you try to observe the wing color will change. So this is one of the application of the smart material. Actuator means actuator something that you push. Very traditional actuator is your syringe. You inject vaccine, you syringe, that is an actuator. But that one is a very old tech, we call it old tech. Normally we won't use actuator for the syringe. Actuator is something that can move. You pump in hydraulic movement and all this, then it become actuator. Recent years, we go into nano technologies. So we have a lot of small robot that you can use for medical purposes. So all these small robot or tiny robot or nano robot, they are smart material that the function as an actuator. Okay, so this is another smart material used in biomedical application. So we think we can. This is a material for blood, support blood and nerve. Okay. So this is how they inject the stent inside the capillary. This under material science. So even though you study mechanical engineering, but if you're good or your expertise in material, you can go into biomedical field. Okay. So another one example for smart material is called MEMs. So if you go into semiconductor industry, then this is very related to mechanical properties, or especially come to material. MEM stand for micro electromechanical system. For example, your airbags, the car airbags. So MEM, they are installed as a sensor. So if something happen, the high impact or there's a velocity changes at a certain limit, then the MEMs will react to that environment. Okay, so this is one of the example how they make MEMs. Micro means very small, 10 power negative 6 micro or micro electromechanical system. One of it is the automotive airbag. So this is the automotive airbag MEMs. So if you look under microscope, there's a few layers. So it come up to 5th layer. Inside our smart car nowadays, we use a lot of MEM sensor. So airbag sensor, tire monitoring, all this. Pressure that you can press on a material, then it give you some reading. That one also fall under smart material. Okay. So again, material just now we look into two classes, sensor and actuator. So this is an example of application. Of course, I don't think I will ask you about smart material. But some lecturer, when they teach this material, they will take this smart material topic and put as an assignment. But my way is a bit different. So I won't ask you to write wrong essay. Okay, nanomaterial is something that 10 power negative 9 sizes, nanomaterial. So how you define another material means the size is 4 below 10 minus 9. Okay. No material. This is fall under microscope. You can see the microstructure. All this you read lah, because I won't ask you this question or for these slides. But I need to feed you some information about the advanced material. Okay, this graph is important. Okay, this graph is important, and also it will conclude chapter 1. Right? So a lot of information that we can extract from this graph. First, every time you look at graph, you look at the axis first. What are the meaning of axis? Y-axis on the left is density. Y-axis on the right also same, but it just help you to read the graph, especially the one on the right. Same scale, it just help you to read more clearly, right? X-axis, it do not have any meaning. It just gives you some relative ideas. In fact, you can overlap all this information in one graph. It just split the category of material on the same graph. So X doesn't have any meanings. Huh? So we have covered for chapter 1, we cover metallic elements, non-metallic elements, we cover ceramic, polymer, composite. So this graph gives you in terms of density. So for metals, they are a bit higher or heavier compared to the rest. Metals a bit heavier compared to the rest, ceramic, polymer, and composite. Okay, the rest you can read inside the box you can read. But the main idea is when you discuss about density and you're comparing with other type of material, where does metal stand for? Okay. So the rest lah, and also from this graph, you know if you focus on ceramic, then what does the density compare to polymer and composite, and so on. The rest you read from the graph. Okay. Now normally, want to highlight is composite. Composite is a bit special because it takes some strength of other material to cover the weakness of some of the material. It become the medium of metal, ceramic, and polymer. Become somewhere between these three. Okay, so this is composite. Again, composite, just now there's one note we mentioned just now. You cannot classify composite based on atomic structure or bonding. There's no specific terms that you can classify, or this is so and so. You cannot. Okay. Next graph, just now is density. Now we look at stiffness modulus or elastic modulus, Young modulus. You learn about Young modulus in your static, right? Yes, no? No. Can you recall what is Young modulus? No. Or you haven't learned, huh? Okay. You have pulling force. Talk about force first. Force, you can have pulling force. The term for pulling force, we call it tensile force. Then you have compress force going in, compressing the body, we call it compressive force. Then you have pull and compress. Then you will have twisting, we call it torsion. And you have, let's say this is fixed. In your static, you learn this symbol. It means fixed to the ground. and you have a force, this one, it will do bending. Right? Now, when you learn about tensile, is pulling, there's one tensile force, tensile stress. Later you learn, this is other lecturer homework. So what is tensile? It's defined by force divided by area. So let's say this is the object. So this is the area, this is the force. So you take force divided by area, you get tensile stress. You know force unit is Newton, area unit SI is meter square. So Newton over meter square, you get stress. Or you call it Pascal. Right? Or you can name as bar if you want, but normally for mechanical we don't use bar. Bar only come into place when you have an air pressure. Okay, so this is the meaning of the stress. So modulus, and also when you pull something, okay, when you pull something, this is before, this is after. So when you pull something, it will change shape, right? Things, if you pull like this, it will change shape. So there's another definition, is called strain. Strain is the deformation. It's a change of length divided by the total length. So let's say this is the change of length. So this is the length. So let's say this is it changed to a certain length. Okay, so this one you have a total change length like this. So you take the change of length divided by length to get this one. So later you learn about in material. Later we go into mechanical properties. We will come back to this definition. In one of your lab experiment, we'll conduct tests like this, right? So there's a equation called Young modulus. Young modulus. We write as capital E. So stress equal to this one. I memorize like this because E and epsilon is about same the shape. So I arrange this one. But textbook, you will see they give you this. Right? So this is how I memorize, but this is a textbook definition. What is modulus Young? Modulus Young is the ratio between stress and strain. Okay. Now, this is stiffness, or we call it Young modulus, is the definition of this one. Right. Now, what happens if you have a high, same material, not same material, different material A and B. One is having, let's say, E1, you have maybe 100 Newton over meter square. E2, let's say you have a low one, only have 10 Newton over meter square. So what does it mean? Right? Now, E1, it means you have higher strength. It can hold more force per meter square here before it breaks. This one very low, means 10 Newton already cannot already. Okay, so later we will come to this definition in maybe chapter 2 or chapter 3. Next week or another week, we will cover on this one. Right? But this is an earlier introduction. Today you just exposed to one new term, maybe new to you, is called Young modulus. Okay, so from this graph, you can see 4 types of material: metal, ceramic, polymer, and composite. Metal, ceramic, they are quite good. They are quite similar. Composite, again, composite is a special category, we call it special category because it's combined, these three become one. So polymer is a bit weak compared to metals and ceramic in terms of Young modulus. Means that you imagine plastic and metals. Which one can handle more forces? Of course, metals, right? Plastic easy to break. So the Young modulus is low. You understand in that way. Then composite, because you take the strength of each composite, it become very good. So that's why it stay like in between metals and ceramic, very high. So for engineering, engineering most of the time you want the material become good, have a very good strength. It can withstand very high pressure, high forces. So the property that we're looking at is always as high as we can. This one no good, means polymer they are not good in modulus, Young modulus or stiffness. They're not very good. Okay, depending on the operation. Okay. This chart is take note. This chart is on room temperature behavior. And different temperature, then different position already lah. Okay, so if we the same graph, if we increase the temperature, maybe 200 or 200, then maybe it will shift already. This one might shift lower already, because plastic, you imagine plastic, you increase temperature, it become weaker already. So this one will shift down. So this one is the room temperature. Okay, two graph already. We just now density, one is stiffness. Third graph. The rest you can read from my slides. Okay. Because when I prepare this slide, I assume you already know what is stress, what is modulus already. Okay, third graph. Third graph is called tensile strength. This is stiffness modulus. Or this one is in log scale. Strength, if you see the strength here, this is tensile strength. It's not the same as the tensile just now. Tensile strength here is that the maximum force that it can handle. This one, metal, it can handle a loss of forces there in mega Pascal, in mega unit, mega 10 power 6. So strength. Later in chapter 2, 3, then we look into this definition, loss of calculation. Okay. So when it comes to strength, you see the polymer catch up with other element already. Just now, the stiffness, the polymer is quite low compared to other. But when we talk about strength, we move up a little bit. It depends on how you fabricate the plastic. Some plastic, they are very hard. Okay. Next graph. The detail you read from my slides. The next one is resistant to fracture. Resistant to fracture means it's very hard to break. So you can see the graph shift already. Metals always very superior in their mechanical properties. But in this case, ceramic moved down already. Ceramic moved down because they're easy to break. Polymer, yeah, same like ceramic. Plastic, very easy to break. But however, again, composite is a special category where it's a mixture of these three, and it always take advantages of the strength element that we want to focus on. So this is the example of the thing. So how useful is all this graph? or how we ask you question by using these 4 or 5 graph here. Normally, it asks you to explain these 3 graphs normally come to application, section C in final, about application, selection of material. Selection of material. So it gives you a scenario. It gives you a scenario. For example, it gives you strength, X value. This one, the resistance to fracture, Y value. Then you use this graph for your understanding. If this one come in question of application or selection material, normally we'll give you graph, then we'll give you some value. So what you do, you use your ruler, go and find the value near, don't need to be very precise, but near to that value, you draw a line, then select that material. Understand, right? Do I need to give you example? Do I need to? Can I? Or give you example? Example. Okay. You have 4 graph, right? I give you an idea. So this is graph A, graph B. So you have properties here. So let's see, this is strength. This is resistant to fracture. Right? So I give you X. So I give you X. You draw an X value here. Then I give you Y. Y may be very high. This is Y. Then just now got graph A, the position of the things. Some are very high, some are very low. For example, so it asks you to select or propose the most suitable material for that products. So according to these 2 scenarios, this is the one selection. Let's say this is material 1, 2, 3. So 2 meet criteria X. Then this one, 1, 2, 3. So this one, 2 and 3 meet criteria Y. Make conclusion. 2 is the suitable material, for example. Okay, so this is like section C or section C kind of question. It asks you to apply what you learn, or give you a chart. Then are you able to use the information you have, come up with a conclusion? So you must argue. You must argue based on the statement in the question. What do you see on the graph, or how you process the graph? Then come with the conclusion. So in final exam, normally if this one come out, how I give you marks? Normally this one will have marks. The line normally will have 2 marks. 2 marks. This statement 1 mark. This statement 1 mark. This conclusion 2 marks. Normally it's like that. So you need to attach your graph together with the answer. Okay. Yeah. So sometimes you can do calculation on the graph also. So in your answer, if you, let's say you write some calculation here, then you come up with the answer. So in your, let's say this is a question 3C. So how you answer? See, refer graph or refer answer in graph. You write in the paper answer sheet there. You You write C, refer answer, or refer my answer in graph. Okay, in graph. So then I will look your answer into there. Okay. So you don't blank lah. Okay, or you can write the answer, the final answer here, then you bracket refer detailed calculation in graph. Okay. Right, this is how you tackle your assessment. Okay, this other chart is called electrical conductivity. The metal very high, of course you know metal very high. Later in chapter 2, 3, when look at the structure, we will explain why metal very high compared to ceramic, polymer, and semiconductor. All right. This you can read, huh? So this one is another chart, electricity conductivity. This one is explaining what you have. The next one is called processing and selecting material. There are some proposed step there, how you propose it. This one you can read. You look at what are the material available to you. Look at the material available to you. Then you look at the operation or application. Look at like this example just now on the whiteboard. What are the material you have? Then what are you going to apply? These are the application requirement. Then you select the material. Okay, so this is another example that tell you the last section of this chapter 1 about processing and selecting material. You are familiar with all these drinks, right? So last time, these are the applications. So what are you as an engineer, or you work as an engineer inside this factory? So these are the requirement for your application. First, you need to provide the container that block CO2 in the container. You know, all these carbonate drinks, they have a CO2 inside, high pressure inside. So you need to contain the pressure inside. Then it need to be non-toxic and non-reactive material. And you have to be relatively strong when you do for logistics or transport. You have to be inexpensive on the costing wise. So, and then if can, this one's for consumer. Consumer, they're attracted by how they looks. So they need to be optically transparent so that you see what is it, or you see what you have. So these are the constraints you have. Then you other. Okay. So what are the materials suitable for this application? Okay, so this section normally we put in the assignment, long essay question. But for our module, I won't put this setting. Okay, so we have basic material, metal, ceramic, and polymer, like what we learned in chapter 1. So we can either choose glasses or the normal one, the metals, aluminum can, right? So you need to analyze what is the pro and cons on that. For example, aluminum alloy, they are good, they are cheap, they are light, but because of the nature of the chemical that you have, you know that carbonate drink, it comes with acidic behavior. If you store your aluminum can long enough, you'll see some drinks come up, some chemical drop out. If you try, I've seen that in my own cases where I bought something, one carton of 100+, and I forgot about it. I keep it in a storeroom. And then during the Chinese New Year, we clean the house. Then only we found. Then below the carton, wow, lots of liquid come out. And then when we take the aluminum can out, there's no like Coca-Cola inside. They seep out from the container, right? So this is some of the material. We as a mechanical engineer, when we study about materials, so this we need to consider this one. These are the proposed process. So you look at the design, processing, and material. So this is a relationship between material, process, and material design, how you do it, right? Again, this one, this section, processing and selecting material, normally it will come in the final exam question, section C, ask you to elaborate on application of material. So this will help you, this chart, this diagram will help you to elaborate what we're looking for. So when it comes to final exam, maybe your test one, section C, this diagram is very useful. You draw design, you draw material, you draw processing, you put in keyword, service, function cost, properties, availability cost, equipment selection, inference, property cost. Then you elaborate based on the statement, based on the question that you have. It's a design question. Okay. This one we covered yesterday, talk about process, structure, properties, performance. So this slide onwards will tell you where are the chapter that will go in when we talk about certain topics. So let's say about steel. We focus most of our time in steel or porous material. Steel, when talk about processing, process, structure, properties, and performance. So processing, we have diffusion. There is a chapter specific focus on the diffusion process, recrystallization for steel, and some diagram. Then structures in chapter 2 later you will see, and so on. And some microstructures things, properties. This one you will see mechanical properties. What are the locate defect system inside there, and so on. Structure crystalline solid. I think this is chapter 2 or chapter 3. So you look at the crystal structure. Then we look at defect later, diffusion, mechanical properties, chapter strengthening, phase diagram, transformation, application process. Normally, this structure crystalline will be in test 1, imperfection will be in test 1, diffusion test 1, the rest will be in test 2. Okay. Same thing, this one is steel, same happen for ceramic, different process, different structure, different properties and performance. Each one of it will also have a chapter on it, right? Glass ceramic and so on. Polymer fiber also have these 4 process, processing, structure, properties, performance, and they have also have chapter for each one of it. Atomic structure, polymer, and so on. And then semicon, this one is more on the final exam scope already. Okay, so these are the few example questions that you can try, right? So this one you will see in the last section of my slides. Some chapter I don't include it because the slide is too much already, so I don't include it, but most of the slide I will include some sample question that you can prepare during your test 1, test 2, or final exam. To test whether you understand what we learn in the class. I show you. There are lots of questions there. For example, the last one. In the sport of tennis, for optimal performance, the racket face and handle must be made of material that very stiff. Stiff means resistant to elastic deformation. Why is this important? So you need to link tensile, density, and so on to answer this question. Of course, in final exam, it won't be this simple question. We will guide you through, like I give you a scenario, more detail. Section A give you some information, you solve it. B will give you more information, you solve it. C give you more information, you solve it. These are the things. Okay. With this, we conclude chapter 1. And the recording. Any question? Everyone good,